All right, let's hit some WebAssign goodness. So, oh, where did I put my pen? There it is. All right, so question one on this reviews thing: how projectiles fired horizontally from a gun that is above flat ground this far, emerging from the gun with a speed of 250 meters per second. So, here is our. Oh, I guess I can't keep WebAssign up. Oh well. So here is our projectile coming out. Boom, and so we're given V naught. So there's some, gun, whatever coming out. And it comes out at distance d above the ground, right? And then acceleration downward due to gravity. Okay, so the first question I think they ask is how long does it stay in the air before it boom hits the ground? So that's pretty easy. Let's start with just a simple change in y. I think most of you guys can probably do this at this point, but let's say delta y is let's say non-negative vy initial, so the initial velocity in the y direction times t minus 1/2 gt squared. Remember, this is plus 1/2 at squared, but then acceleration is negative g, so minus 1/2 gt squared. We're using the standard, positive y going up, positive x going horizontally, so this is all good. Initial velocity in the y direction is 0, so this is 0, and which means this all goes away. So what we get is delta y is negative 1/2 gt squared. Well, how far does it fall before it hits the ground? This distance d, which I've called d, okay? So I say negative d, this is delta y, is negative 1/2 gt squared. So that means, let's multiply both sides by 2, and then divide both sides by g. So this is 2d over g on this side, and that equals t squared. So I'm just going to square root over here instead of writing the squared there. And that should be our time. So that's part A. For part B, what was part B? Part B was horizontal distance from the firing point before it strikes the ground. Well, so we know how long it takes to strike the ground. Now this is pretty easy, right? So delta x, which is how far it goes before it strikes the ground, is velocity in x initially times the time. And since there's no acceleration in the x direction, this is purely a projectile motion problem, no x acceleration, x is our horizontal, this is all there is to it. Velocity in the x direction is constant. So, and it just equals this v naught here. So v naught times t, and this is t from the before, the square root of 2d over g. And that equals how far you go in the x direction. So there's your part B, that was your part A. And then for C, what was that? What is the magnitude of the vertical component of the velocity that strikes the ground? Right. So probably easiest way to find that is just, let's see, velocity in the y direction is initial velocity in the y direction, which was 0, minus g times t. This is plus acceleration in y times t, but acceleration in y is negative g, so that's how it works out. So initial velocity in y is 0. Negative gt is our well, we know t. I don't know what I'm saying here. So let's see. Hold on. Vy, which is this, equals this part is 0. In fact, I'm just gonna let's do blue. All right, 0. So Vy is negative gt, so negative g times square root of 2d over g. Okay, so what this really equals, Vy equals negative square root of 2dg. Bada boom, bada bing, baby. I'm going to pause while I try this and just make sure I've got it correct. Okay, welcome back. So I've figured this out for my answers. For my numbers, I started at 89 meters above flat ground. I think everybody must have had this 250 meters per second. So projectile stays in the air 4.26 seconds, goes a little over 1,000 meters, and it's going a little over 41 meters per second down when it hits the ground. So there you go. I'm going to start a new video for number 2 because that is this long, slopey,